In this section, I'm going to start talking about a couple of special log functions, and one log function is actually called the natural log function, and we use ln to represent the natural log function. So if you see a function with ln, that just means that's the natural log function. But what that tells you is that this is a shortcut version. This is an abbreviation for saying the log of x base e. So the natural log function is simply a log function where e is the base. And if you were to graph this function, it would look, very similar to any other log function, like maybe log of x base 2 or log of x base 3. So anyway, log of x base e, again, we don't write it this way. We just say the natural log of x and write ln of x. All right. Now the common log function, another function that we can use in abbreviated form, is the common log function, and we identify the common log function without identifying a base. So the common log function would be just logx. So if you ever see logx, that is simply the log of x base 10. So that would be the shortcut for the log of x base 10. And of course, the log of x, the common log function, is going to look similar to the natural log function. But remember earlier I told you when the base was larger, the function flattened out a little bit quicker. So this function would flatten out a little bit quicker. And if you wanted to graph these, you could do an x and y chart like I did on some of the other graphs to graph these functions. Okay, now as far as graphing these functions, as far as graphing techniques, if you wanted to graph, let's say you wanted to graph minus the natural log of minus x. Well, the natural log of x function, all right, that looks like this. So if you wanted to graph, let's forget about this minus for a minute. Let's just say you wanted to graph the natural log of negative x. Well, by graphing the natural log of negative x, that would just reflect the graph about the y-axis. Let me see if I can kind of give you, I don't have much room over here, but let me just show you. If you reflect the graph around the y-axis, it would look something like this. All right. Well, then when you do the minus in front of it, that takes that graph and reflects it about the x-axis. So if you take that graph and reflect it about the x-axis, it would end up looking something like this, off in this direction. Okay, so that's what you would end up with there using your graphing techniques. Now this one is based on the common log function, so replacing x with x minus 3, that just shifts the graph 3 units to the right, and the 2 shifts it up 2 units. So let me see if I can do that for you. If we shift this graph 3 units to the right, that would move this point 1, 2, 3 to here. And then if we shift it up 2 units, that would move it up 1, 2, so it'd be up here somewhere. All right, so 3 units to the right, shift it 3 units to the right, and 2 units up. Now, this is the vertical asymptote, so we'd also have to shift the vertical asymptote 3 units to the right, 1, 2, 3. That would just be right here, just to give me a guide here. All right, so the graph would do something like this. So it would be basically the same shape. It would just be shifted 3 units to the right and 2 units up. Okay, now just like I did before when I had you evaluate exponential functions with a calculator, I want to make sure you can evaluate log functions with the calculator. So most calculators will let you evaluate the common log and the natural log. So just make sure that you can evaluate the common log of 235 on your calculator and get the answer that I got here, which is 2.371. And then make sure you can evaluate this function at 25.03 and get the same answer I got here. So you just take 3 minus and then grab the natural log key on your calculator and plug in 25.03, and then evaluate that, 3 minus the natural log of 25.03, and you get negative 0.22. Now, so that's the introductory section on logs completed, but we still need to talk about log properties. Now, when I say log properties, I'm not talking about the properties I talked about in this section. I'm talking about like operational properties, and you'll see what I'm talking about in the next video.